Hi guys, this is Jonathan Lambert with Maths and Stats, and in this video, another video in our series of videos dealing with calculus and limits, and specifically looking at epsilon delta proofs. And in this video, we'd like to use the definition of a limit to show that the limit of x squared as x tends to 3 equals 9. Okay, but let's just recall one or two facts. First of all, let's just recall the definition of a limit, an epsilon delta definition of a limit. So let's just recall that given a function f, so given a function f, we say that f approaches the limit L near a, okay, if for each and every epsilon greater than 0, there exists a delta greater than 0, such that for each and every x satisfying the condition that 0 is less than x minus a is less than delta, that this implies it implies that the absolute value of the function minus the limit f of x minus L must be less than epsilon. Okay, so ultimately what we need to do is that if we're given any epsilon greater than 0, we're going to need to find there exists a delta greater than 0. We need to find that particular delta such that this, for all x that satisfy this condition here, from this condition that we can infer this condition over here. Now, in this particular case, what we'd like to show is that the limit of x squared as x tends to 3 is equal to 9. So in this case, okay, what we need to show is that if for each and every epsilon greater than 0, that there exists a delta greater than 0, such that for each and every x satisfying, okay, so don't forget, let's say we found the delta, so satisfying this condition, that 0 is less than the absolute value of x minus where x is tending to, so minus 3 has to be less than delta, that from that fact that implies that the function, which is x squared, minus the limit, which is 9, must be less than epsilon. So what we really need to do, once again, is we need to find this particular delta value. So just let's look at this implication. The implication has the premise and it has the conclusion. So why don't we just take the conclusion and explore, see if we find values of x that are less than some, let's say, some multiple of epsilon, because if we can find them values of x that are less than a specific value that includes epsilon, well then why don't we use that particular epsilon or that particular value, that multiple of epsilon, as our particular delta value. So let's consider f of x minus L is less than epsilon to see can we find a particular delta value. So from this particular fact, therefore we have, considering this, we have that x squared minus 9 must be less than epsilon. Okay, so x squared minus 9 is f of x minus L must be less than epsilon. And what we can do is we can actually factor this particular quadratic. So this implies that the absolute value of x minus 3 times x plus 3 must be less than epsilon, okay, which implies that the absolute value of x minus 3 times the absolute value of x plus 3 must be less than epsilon, which implies, see, we want to reduce this down. Okay, we want to reduce this conclusion down into a form that looks like the premise. And you can see that the premise has the absolute value of x minus 3, which is here. So let's see what is x minus 3 less than. Let's see what is the absolute value of x minus 3 less than from considering this conclusion. So this implies that the absolute value of x minus 3 is less than epsilon over the absolute value of x plus 3. So what we have here is we have our form, our premise, which is, this is in the form of x minus a is less than some value here, and this value is effectively delta. But we have a bit of a problem because we want delta in terms of epsilon,